Hello everyone. So today I'm going to show you some of my favorite planets in this program called Space Engine. So first let's select this one. This is one planet I found. This is a cold lacustrine aquaria with life. So we'll select that and we will fast travel to it. Now, most of the planets we're looking at here today are procedurally generated, which means that they are likely not actual planets, but these planets are all based on the physical properties of planets that we do know. So far, NASA has discovered about 5,000 confirmed exoplanets outside of our solar system, and there are another about 10,000 exoplanets waiting for confirmation. So a lot of planets out there probably do look like some of these samples that we're going to look at today, but these particular ones are procedurally generated by Space Engine based on what we know of the physical properties of planets out there, and of course based on the properties of the planets in our own solar system that we have studied extensively. So the reason I like this particular planet is because it has just these beautiful mountain ranges, and they remind me of the Himalayan mountains and the Karakoram range here on Earth. So absolutely beautiful, and these mountains do seem quite high. Like a lot of them seem to be at least the height of Mount Everest on this planet. And let's take a quick fly through. We'll get a bit closer, see what they look like. I'll make sure the graphics settings are set to pretty high. So let's set this one to custom, and we will increase the environment map resolution. Actually, let's set this one to high, and that's good there. Okay. Yeah, let's check that out. Okay, that is looking very nice. And then we can just fly through, just like Microsoft Flight Simulator. You can explore all of these planets up close. And it looks like these mountains just stretch for hundreds of miles on this planet. And you can see the clouds moving over them, so I'm going to speed up time. And you can see the clouds moving overhead. Let's set time back to normal. Now, besides these beautiful mountains, one other thing that I like about this planet is that it has a very nice ring system right above it. And you can see the rings are being lit up by the sun because it is daytime right now. But what would happen if we wait until nightfall? I'm going to increase the passage of time. And you can see the sun overhead. Let's increase time further. So there we go. And that's one of the moons or a planet. And we're coming down towards sunset. Now we can slow time down a little bit again. There we go. Okay, so we're getting to sunset. You can see these beautiful mountain peaks right in the front. And let's watch the sunset from this place over here. Actually, let's go to the highest mountain in the land. And we can watch the sunset from here, from the top of this mountain. Okay, the sun is going down. There we go. And it is below the horizon. Oh, we saw that green flash. We see those on Earth sometimes as well during sunset. And now you can see right above us, this beautiful system of rings is going to start getting brighter. So as the sun keeps going down, we'll give it a little bit more time. There we go. Okay. So as the sun goes down, this beautiful system of rings is still being lit up right above us. And that is what it would look like if we lived on a planet that had beautiful rings like this. I'll increase the field of view a little bit. So right overhead, absolutely beautiful view. Now this particular planet also has what appears to be a moon over there. Let me click on that and get some info. Yep, that's a moon about 60,000 kilometers away, so quite a bit closer than our moon, which is 384,000 kilometers away on average. So we can actually travel to that moon and see what the planet looks like from that moon. Let's turn this off. Okay, so we will just start flying towards that moon. We pass through the rings. Oh, that was too fast. Let's fly through the rings again. I love flying through the rings of planets like Saturn. Okay, there we go. We're coming up to the rings. Should be billions of tiny particles that make up the rings. Oh yeah, there we go. Okay, now we can fast travel over to the moon. And that moon actually looks a lot like our own moon, except it seems to have some large regions over here. I don't know if that's, or what kind of material that is. Maybe it's rich in limestone or something. It has these large patchy regions. And it's reasonable that a lot of the other moons out there in the solar system would look like our own moon as well. So let's go land on this one somewhere over here on one of these hills. That way we will get a better view. There we go. Okay, now since this moon doesn't have an atmosphere, we see a clear dark sky even during the daytime. And this is the planet. Absolutely beautiful view with that huge system of rings, and also you can see several other moons orbiting that planet as well. Let's get a bit more information on that particular planet. So we can see that that planet is, let's check the physical properties. So 15,000 kilometers across, so a little bit larger than the Earth. A little bit heavier than the Earth as well, about 1.3 times heavier. And of course it is very cold, minus 189 degrees Celsius average temperature. So probably not a place you'd want to go for vacation. But this is what it would look like if we lived on a moon around a planet that had rings. So beautiful view. And this particular planet actually has other moons as well. So if we pull up this at the top, you can see several of the planets in the system with several moons. And this one seems to have 8 moons in total, and we are standing on one of the little moons here. So, whoa, it looks like a little cave over here. Okay, so let's go explore some other worlds. Now I had saved a couple of planets here, and yeah, let's go over to this one. Now, whether or not these planets exist, there is no way to know. The ones in this program are procedurally generated based on what we know of the physical properties of planets, both in our solar system and outside the solar system. And so far, we have discovered over 5,000 confirmed exoplanets outside our solar system, and about 10,000 other candidates waiting to be confirmed. And that's out of likely 100 billion or more planets in our own galaxy alone. So it is possible that just about any planet we see in this program, well, there's a planet out there that probably looks like it. And there are near infinite combinations of physical properties that would determine what these planets actually look like. Now, this particular planet, I just really love this planet. You can see what appears to be these are clouds, but right underneath it has this purplish glow, or this purple coloration in these large patches. Now, I'm not sure what elements you would need to have present in the crust to get this kind of a purple color, but I just absolutely love that. And it does appear perhaps those could be lakes as well, some of these purple regions. I don't know, but let's go find out. We'll go land on this planet and then see what it looks like up close. Going in for a landing. See if that's water or if it's land. Oh yeah, there we go. Ah, okay. Just had to give it a second to load. Okay, so yeah, it is land. Almost like a desert with some pink coloration in some of the rocks. So this is a bit of a desert planet. You can see some sand dune looking things. Let's go higher up and we'll go explore a little bit more. This planet appears to have fairly varied terrain as well, just like the Earth. And these look like some interesting mountains, so we can go through the clouds. We'll go pull up right here on the top of this mountain. And it has some of this greenish coloration in the crust as well. Again, it could be anything. Could also be grass, actually, if this planet does have some life. Yeah, let's get a bit more information about this planet. Okay, it's a cold, arid aquaria. And these mountains are pretty high. We're at about 12-kilometer elevation right now. Atmosphere contains nitrogen and ammonia, carbon dioxide. Interesting. Oh yeah, and it's got some pretty high mountains as well. Wow. So beautiful, beautiful place. There's the sun. Let's take a look at the sunset on this planet. Oh, right now it's sunrise time, so let's speed things up a little bit so we can get a nice sunset view. Get front row seats to the sunset. Oh yeah. Oh, I think I missed it. Let's go back. Oh yeah, I think I did miss the sunset. Let's just go higher up and get another view of the sunset from above the clouds. And I think as the sun sets, we should start being able to see some stars. We might be too high up. Oh yeah, there we go. Oh yeah. Beautiful sky. Okay, let's go up into space and check out the other side of this planet. The side that is still in the sun. Oh yeah, look at that storm. Absolutely humongous storm right above us. Actually, let's go to this little moon. This is one of those mini moons that are usually 20-30 kilometers across. And we'll go land on the surface of this moon here. And let's take a look up and see what that planet looks like. Oh yeah, there it is. Wow. We are pretty close. This moon, let's see how far away that planet is from us right now. So current distance, if I can find it, is about 15,000 kilometers. So we are actually very close to this planet. This is probably close to the distance that that the two little moons of Mars orbit Mars at. So the planet would look absolutely massive in our sky if we were that close to the Earth from our moon. Now you can see that massive hurricane. It's just an absolutely massive system going over the planet. Now this would be quite a view. I think the view would probably look more like this if we were that close to our planet. And if we were on a moon. And this planet seems about the same size as the Earth. Let's take a look at the actual, so distance is 15,000 kilometers. Diameter is about 14,000 kilometers, so it is a little bit larger than the Earth. So beautiful. And actually, let's speed up time a little bit. Oh yeah. Set that back. Okay, next planet that I had saved here to share with you, it is this one. It is a temperate mega Neptune. So the planet is very much like Neptune in our own solar system. And this is quite a large one. Right now we're looking at it from a distance of about 200,000 kilometers. And this planet is about 100,000 kilometers across. So this is a big one. So I think that's 100 and yeah, that's almost the size of Jupiter actually. This is much larger than Neptune in our own solar system. So let's see if there are any cool moons around it that are not exactly in the plane of the rings. So I'm only seeing one moon, so let's go over to that moon, and we'll go land on this side. And let's take a look up. So, oh yeah, there it is. So realistically, I think it would look about this size from that planet at this distance. And now we're at about 260,000 kilometers away, and you can see this big storm just underneath the rings. Now, if we travel towards that planet, we're traveling at about 3% the speed of light. We'll go through the rings. I don't know if this purple coloration of the rings is realistic. I don't know what exactly physical properties would be required to give a purple coloration like this. But, oh yeah, there we go. Going in, slowing down. And this reminds me very much of that picture that the Cassini space probe had taken when it was traveling through the rings of Saturn. It looked very much like this. Oh yeah, there we go. Okay, I never get tired of flying through the rings of planets like this. Now we'll just go faster, and that is a massive storm. That looks like very much like the storm around the Great Red Spot on Earth. On Jupiter in our own solar system. So if we travel closer to it, we'll see if we can fly over it. Let's change the lighting a little bit so we can see. Okay, yeah, this is what it would look like. Now, the atmosphere of this planet doesn't have as much color as Jupiter, so it all looks like various shades of blue. Oh yeah, I definitely don't want to go too deep into that. It's kind of scary. But yeah, it's a pretty cool planet. Some activity going on in the upper atmosphere there. You can see some festoons. And I think we might also get some aurora if we go up to the poles here. No, this one does not seem to be as active as some of the other planets. Now then, there is this interesting planet that I had found, and this is a temperate arid terra with life. So it's an Earth-like planet, but seems to be a bit dry, and average temperature of about 6 degrees, but it does have life either on the surface or just somewhere just underneath the surface. And let's fly down here, get a closer look at what it's like. Yeah, those look like some ice sheets. Okay, so quite a bit of ice on this planet. And the atmosphere has a greenish tinge. I don't know what gas would cause that. Let's see, the atmosphere is pretty tenuous here. So it's got water vapor, nitrogen, and oxygen in its atmosphere. Let's go higher up and find some interesting spots on this planet that we can go and explore. Besides all of these massive ice sheets, looks like there's some desert-like regions as well. There may have been some glaciers at work in the past on this planet. Okay, these are clouds, not glaciers. Oh, there we go. Let's go to the top of one of these higher peaks and we can take a look around. There we go. Oh yeah, pretty nice view, kind of like a cool desert. It reminds me of the Thel Desert in Pakistan that I visited not too long ago. Now let's take a look and see if this planet has some other interesting places that we can explore. We can actually remove the clouds to give us a better view. There we go. Okay, let's go around the planet a little bit. Oh yeah, it looks like there's a big... Is that a river or a canyon of some sort? Can bring the clouds back now. But so what is this? Oh yeah, it looks like some massive canyon. Go land over here. So you can see it on both sides. Oh yeah, this is massive. This looks like Valles Marineris on Mars. We are inside the canyon, so it's hard to see right now, but yeah, that's a pretty large canyon. Now if we zoom out again, and on this side of the planet, there seems to be, oh yeah, there's a mountain here. This looks like a large volcano, reminds me. Oh, I went the wrong way. And there we go. Now we can fly to it. This volcano reminds me a lot of Olympus Mons on Mars. So it seems to be the same kind of shield volcano as Olympus Mons. And if we go land on the surface, okay, this is bigger than I thought. So that's the caldera. That's where the lava came out at some point. We have to get to a higher point. Okay, there we go. That's pretty good. Yeah, so caldera on that side, and on this side, we're looking down maybe, I don't know, 100 kilometers or so through this thick greenish atmosphere. And it's a beautiful sight, and I think the sunset would actually be very nice on this planet, except for the fact that this planet appears to be tidally locked to its star, so it doesn't have a sunset, which is why nothing was happening. It's always the same side of the planet facing the star here, so one side would be very warm and one side of the planet would be very cool. And looking down there, you can see this green haze just filling the valley below. So if one side of the planet is always facing the sun and the other side is always facing away, then that means that the other side would be pretty cool. It should get some interesting views. Let's go over to the other side over here. Let's see what the sunset would look like. I guess not sunset, more like twilight, or the whatever the equivalent is for this planet. We'll go land on some of these. Oh, that was much faster than I thought. We'll go land on one of these high peaks, and these mountains remind me so much of one of these places I've seen pictures of in China. Let's go to this mountain. This is high. Wow, this mountain is high. This is like the Mount Everest of this planet. Wow, look at that view. It's absolutely beautiful. Now our height right now from the surface of the planet is, or I guess the sea level equivalent of this planet is 16 kilometers. So this mountain is about twice as high as Mount Everest. And this is probably not even the highest one, but this is what the sunset would look like. This greenish glow. I mean, you can get green from cyanogen gas. So if there's a lot of cyanogen gas in the atmosphere of this planet, that might explain the green coloration of the atmosphere. So wow, that is absolutely beautiful. Okay, so let's take off and explore our next planet. But before we do that, I kind of want to fly through these mountains here. Whee! Okay. Now, let's go back up. Okay, we'll say goodbye to that planet. Up next, let's go to this one. This one is a cool Lacustrine Terra with life. So we'll fly over to this one. There we go. Now, that is a beautiful planet. You can see right away. But let us go in on one of these volcanoes. Now, the reason I liked this planet was these massive volcanoes that are completely covered in ice. Now, here are two of them. Now, you can just see as you're approaching the planet, these massive volcanoes are just jutting out into the lower atmosphere. So let's fly. Let's take a little trip. We'll get closer down so we get a better view. But this planet's atmosphere seems fairly thick. Let's get some information on that. Oh, it's a fairly small planet, about 8,500 kilometers in diameter. So about, what is it? 3/4 of the diameter of the Earth. Its mass is quite a bit lower as well, 0.3 times the mass of the Earth. But it does have some organic multicellular life on this planet. So there it is. We are approaching the volcano. And as you can see, the volcano starts down here, and the top 1/3 of it appears to be covered in ice. So this one looks a bit like Mount Kilimanjaro. But let's see how high this one is. And look at the size of that massive caldera at the top. This must have been one heck of an explosion, a giant volcanic outburst at some point in the past. And of course it is filled with ice. This could likely be carbon dioxide ice like Mars. This planet's atmosphere does have carbon dioxide as well, and water vapor. Could also be water vapor like the Martian poles. Now let's slide down into the center of this caldera. I'll jump. Whoa! And how far away are we coming down from? So 16 kilometers. So this is about half the height of Olympus Mons on Mars, but about twice the height of Mount Everest. So let's go to the middle of this giant caldera. There we go. Okay. Now standing in the middle, you can see just how massive it is. You can see the walls on the outer perimeter there. And those must be 20-30 kilometers away from us in each direction, or more in this case. So that would be, wow, quite something. And now visualize the volcanic eruption that created this caldera. Absolutely massive. Okay, let's go back out. We'll stand at the top of this part of the mountain and take a look outside, take a look outwards, see what things look like from up here, from the top of the world. Okay, so the atmosphere is kind of hazy. We can't see very much in that direction. Let's fly over, and we'll just get closer and explore. That's the problem with making things realistic. Sometimes the sky conditions are not great. And I'm sure some of the atmospheres on these other planets have pretty hazy viewing conditions. So this one reminds me a lot of Mars, the planet, but probably colder. Average temperature is minus 86 degrees. And like Mars, it does have some massive volcanoes. Now if we zoom out, take a look at some of the rest of the planet, there are volcanoes all over the place, these massive ones. So at some point in its past, this planet was likely very volcanically active. And oh, this one does actually still have some water. So this could be what Mars looked like in its earlier years. So at about 8,000 kilometers, this planet is bigger than Mars. But it does have these huge lakes, and it does have volcanoes just like Mars. And at some point in the previous history of Mars, Mars also probably had, well, likely had water. And yeah, it lost it. I guess Mars was not big enough to retain its atmosphere, and ended up losing its atmosphere and its water. And it's possible that the same thing could happen to this planet. It's only about 1/3 as massive as the Earth, so that might not be enough for it to keep its atmosphere. So looking from the surface, you can see the lakes out in the distance, some of these ice sheets. Let's fly over to one of those lakes. We'll just pretend we're paragliding down over the surface, or using a wingsuit or a squirrel suit. Go faster. There we go. Okay, we have approached water. This is the ocean. Okay, we'll go take a walk along the beach here. Oh, we're under the water. Yeah, that scares me. I'm gonna get back out here. Who knows what lurks below the surface. But yeah, beautiful. Okay, we'll zoom back out. And our last planet is this warm marine terra with life. Now I found this planet while flying around. Ooh, look at the atmosphere. So sunsets would be beautiful on this planet. But the reason I love it is the green coloration. Just very, very dark green. And the atmosphere of this planet contains water, oxygen, nitrogen, and carbon dioxide. So fairly similar to our own. And this planet is actually quite big. It's bigger than the Earth at about 15,000 kilometers and weighs almost twice as much as the Earth. So it's almost like a super Earth, you could say. Now, if we go and land somewhere on this planet, let's find an interesting place to land. Okay, this looks like an interesting place to land. Wow, look at that canyon. This is like the Grand Canyon on Earth, or Valles Marineris on Mars. We'll just fly through it, pretend we're in a small plane flying through this canyon. Let's go lower. This reminds me of a trip I took to BC in a small plane, and we were flying just at the level of the mountains on the sides for a while. It was quite an experience, and this is a little bit of what it looked like actually. Whoa, let's go faster. Whoa, whoa. Oh, okay, I'm not very good at this. But yeah, it's nice to be able to fly through, and we're going towards a lake. I mean, it's possible this canyon was carved by some river at some point in the past. And right here we are. Oh, beautiful water. Well, the average temperature of this planet is 66 degrees, so you would have liquid water, and that's actually quite nice. Wow, look at that. Look at that beautiful lake. Oh yeah, under the water. And let's come back out over here. So, very nice Earth-like planet. Beautiful lakes. I would love to kayak on the lakes on a planet like this, except it might be too warm to be comfortable. But again, the atmosphere is very, very cool on this one, just the greenish tinge. Let's see if we can... Where's the sun? I want to see what a sunset would look like on this planet, and whether this planet is also tidally locked to its star. Oh, there's the star. So we'll go back to the planet. And we'll go land somewhere. Yeah, somewhere on the surface. Anywhere here is fine. And the star is up there. So let's speed up time. See. Oh yes, this planet will have a sunset. This one is not tidally locked. Okay. So as the sun starts going down, normally the sky is green, but as the sun starts going down, you get this nice shade of purple. Okay, speed it up a little bit more. Oh yeah, purple sunsets, absolutely beautiful. This makes sense as the atmosphere seems fairly thick, and the shorter wavelengths of light are being absorbed by the atmosphere, so you end up with a purplish reddish sunset. Oh yeah, and you can see one of the moons as well coming down for the sunset. There we go. And then once it gets totally dark, oh, some nebulae in the sky. That would be a beautiful sky, and you can see the same Milky Way that we see from that planet, because that planet is also in our own galaxy, somewhere fairly close by. Okay, and then this is sunrise time, and the sky goes back to being green. Oh, unless this planet has multiple suns, let's take a look at. Let's zoom out a lot and see what kind of planetary system this is. So it has some moons around it, or at least one major moon. And there's one star. Yep, this one only has one star. And this is a class G star, which is the same as our sun. And sun-like stars, class G stars, are actually fairly rare. They only make up about 3% of all of the stars in our galaxy. So they are fairly rare, but in this case there is a second star right behind, and that other star is, yeah, so this is a solar system with two suns. No wonder the morning came so quickly after sunset on our planet. So there are actually two suns in the sky here. That explains it. And this was our planet, the one that we were let's go back to our planet, this one here. So we'll just fly back to it, and when we look up from here we see both of the suns are fairly close to each other. Those are both orbiting each other. Those are the ones you see at the top left over here. And then this planet is orbiting the common center of gravity in this planetary system. And there are, of course, several different moons as well. Let's go to this moon around the planet and see. No, I guess this is less of a moon and more of a little moonlet. A tiny asteroid-like thing, perhaps like Sirius, that was captured by this planet. But wow, look at the view of that planet from the surface. We'll set it to realistic lighting. So this is nighttime right now, but this moonlet does not have an atmosphere, so it doesn't disperse the light. So this moonlet is probably not the best place to look at this planet from. Let's see if we have another moon nearby that we can use. Oh yeah, this moon here. So we will go over to this side of the moon. Oh, that's actually a beautiful moon. The yellow on the surface probably comes from sulfur. So this is kind of like Io in our solar system. And the red, I'm not exactly sure what elements or compounds would be required to make that red, but wow, that is a beautiful view. So that is the planet we were looking at, the very green one. And again, the sky looks black in this case because this moon does not have an atmosphere, so we can see clear through it even during the daytime. And yes, you can see stars during the daytime from any moon or planet that does not have an atmosphere, because there is nothing in the sky to scatter the sun's light. This is why if you were standing on the moon, you'd be able to see the stars, but in the Apollo pictures you cannot see the stars because the camera's exposure is set to be able to see the surface. So whenever you look at the surface, the stars in the sky disappear because the camera here automatically adjusts for the surface. And if we look up, the surface becomes too bright, but now you can see the stars. So this is why you can't see stars in the Apollo pictures. See how they just disappeared? It's how the camera works. I'm sure most people already knew that, but for anyone among the viewers who was wondering why you can't see stars in the Apollo pictures, this is why. Okay, well, this was the last planet that I had to show, so thank you so much for watching. And yeah, if you like this, I'll do another video and explore some other stars, other planets, both actual planets and some hypothetical procedurally generated planets like this one. Okay, clear skies, and see you next time.